Hello, in this video we will be recreating the part drawing for example 2 from lab lesson 2. So I have my part open up in Inventor. This is the part that we walked through making, and now we're going to go in the reverse direction and we're going to recreate the original drawing that we were given in order to make the part. So to do this, I'm going to open up a new drawing in Inventor. So I'll go File, New. You'll see I already have the 1P A3mm drawing template saved to my templates, so now I can open it directly from the Create New File window. So I'll press Create, and our drawing will open up. So the first thing I'm going to do is fill out the title block in the bottom right corner. To fill out the title block, I go to File, iProperties, and then Summary, and I can specify the title of this drawing, which is going to be Lab 2 Example 2. I can specify my name under author. So I'll put my name in, and then you can put your MAC ID under subject. Once we have all that information, we can click apply and close, and you'll see it shows up in our title block. Our title block is almost complete. We are missing the date and scale, but those will appear once we place our views. You'll also notice that this title block shows the sheet size, which is sheet size A according to our template file. But if we look at the drawing that we were originally given for this part, it's actually on sheet size B. So we can change the sheet size by going to our model browser and right-clicking on sheet 1. Then we can select Edit Sheet, and in this window we can change the size from A to B. So sheet size B will be 11 inches by 17 inches, which is a bit larger than sheet size A. And now we can go ahead and place our views. We have our title block filled out, so that's our next step. So to place our views, we select Base. And because my part file is already open in Inventor, Inventor automatically selects that part for placement in my drawing. So this saves me time because now I don't have to go and find the file path for the part that I want to place in my drawing. Instead, it's automatically filled out. So here we can change the style from hidden line to hidden line removed or to shaded, but for our multi-views we want to leave it as hidden line, and we can also change the scale. So in this drawing we want a scale of 3/4. Now I can drag my front view down to the bottom left corner here, and I can just move my cursor up and click to place the top view. I can do the same to place the right view, and I can do the same to place an isometric view. Once I have all my views, I can select OK. And there we go. So everything looks pretty nice. Afterwards, I can just hover over a part until a red border pops up, and I can just click on that border to drag it if need be. So if we want, we can change the isometric view to be a shaded view by right-clicking on the isometric view and selecting Edit View. And here we can change the style to shaded. So I'll do that for this example. Now we have the shaded view in the top right corner. And now that we have all of our views, it's time to start adding annotations. So this includes center marks, center lines, dimensions, and any notes as well. So I'm going to start with the center marks and center lines. To add these, I'm going to go to the Annotate tab, and I'll start with center marks, which we can select right here, the center mark tool. So center marks belong on any circular features. So in the top view, you can see we have the top 2 cylinders of our part. So I will just left click on their edges to add the center marks there. We don't have any circular faces on the front view, so there are no center marks for that view. But we have quite a few in the right side view. So we need to add center marks for all of our holes. And we also have these round features that also have center marks. They just happen to be coincident or aligned with the center marks of our holes. But we can select those edges as well to add center marks as appropriate. So that's it for center marks. Now it's time to move on to center lines. So we have 2 tools at our disposal for center lines. One is just this center line tool, where you click the 2 extents of your center line. Another is this center line bisector tool, where you select 2 edges and then it will place the center line between those 2 edges. So I'm going to use this center line bisector tool, and I'll start off in the top view where we know that we need center lines for the cylindrical features at both ends. So I'll just select these hidden lines to generate a center line there. Same on the other side. And we also need center lines for all of the holes on this part. So I'll just add those center lines using this tool. In this case, the center lines are short because the holes are short, so they just show up as solid lines. We do the same on the other side. And now we can move down to the front view. So again, we'll need the center lines for the cylindrical holes at both ends of the part, and also for the holes on the flange, but those in fact align with these center lines, so we already have that. We also need center lines for these top cylinders because they are cylindrical features. In fact, they're holes as well. And we can do the same in the right side view, where the only center line we have to add is for the top cylinder. Okay, so now we've added all of our center marks and center lines corresponding to axes of cylindrical features, but we also have to remember that center lines can also represent planes of symmetry. And in fact, we have a plane of symmetry that we should be able to see in the top view and in the front view. So I could go ahead and use the first center line tool to indicate this center line for this plane of symmetry by clicking the two ends of my center line and then right-clicking and pressing Create. But alternatively, I know that these center lines are actually placed on top of one of the origin planes from my part model. So I can go to the model browser. I can go to the part model corresponding to the front view. You can see that it gets highlighted in red when I hover over it. And I can go into the origin folder and I can make the YZ plane visible by right-clicking and pressing Include. So now we have this annotation for our plane of symmetry. I can do the same thing for the top view by going into the origin folder and making the YZ plane visible. And now we have all of our center marks and center lines for both the axes of cylindrical features and for our plane of symmetry. So now we can move on to the next step, which is adding some of our dimensions. So I will start with the front view. I'll go and click the Dimension tool, and I will dimension the width of features from this plane of symmetry represented by this center line in order to have that information. So I'll start with the smallest dimension, which is going to be the distance from the center line to the central axis of this top cylinder, which is 30 millimeters. I'll then work my way out. So next we have the extent of the rectangular prism. And then we have the extent of the loft feature. And then of the cylindrical feature. And you can see this is a lot like dimensioning sketches when we're modeling a part. Now I can right-click and press OK, and I'll just try to rearrange this to make it a little neater. You'll notice that I'm using a certain style of dimensioning called baseline dimensioning, where everything is dimensioned from a specific baseline, in this case our plane of symmetry. So now we have the main dimensions indicating the widths of certain features in this part, but we also need to have some of the height information and the depth information. So let's move on to our right side view, and we'll add some height information in this view. Specifically, we'll indicate the overall height of the rectangular prism, which we can also see in this view is equivalent to the height of the outer extent of the flange. We can also indicate the height from the base of our holes. So this shows that the central hole is aligned horizontally with the two holes on either side because the center marks are aligned and they're all halfway up the part. We can also dimension the position of this center hole from the back edge of our part. That happens to be 25 millimeters. And to get the complete locations of these holes on either side, we can dimension their horizontal distance from the center hole as well. And we'll do both holes to indicate that they are positioned symmetrically about this center hole. In this view, we can also indicate the diameter of this center hole to be 24 millimeters. And we can also indicate the radii of some of these curves that make up the outer edge of our flange. So this top curve we can see has a radius of 20 millimeters. And since there's two of them, there's one on the top and one on the bottom here, I'm going to add an additional note in this dimension of 2 times to indicate that this feature is repeated 2 times on either side of the hole in this flange. We can also dimension the radii of these rounds to the side, which have a radius of 7.5 millimeters. And again, there's 2 of them, one on either side of the main hole. So I'll add the 2 times note in that dimension as well. In this view, we can also see the height of this top cylinder. So we can dimension that as 15 millimeters. And we can also dimension its distance from the back edge of the part, which is 15 millimeters. So notice as I go, I'm trying to align the dimensions nicely with the shorter dimensions closer to the part to make it cleaner and easier to read. It's okay if the extension lines cross over like this, as long as these main dimension lines don't cross over. That's what we want to avoid. So now we have most of our dimensions included in the right side view. We are still missing some important information about this cylindrical feature, namely its outer diameter, as well as the diameter of the top cylinders on this part. So we can add that in the top view. So I'll continue with the dimension tool. I'll dimension the diameter of this cylinder, and I'll also dimension the diameter of the top cylinders, since this is the only view where these cylinders appear as circles. And finally, another piece of information that we're missing is the total depth of this rectangular portion. So that's another thing that we can dimension in the top view. So I'll add that in here as 50 millimeters. And now if we zoom out, it looks like we have most of the information required to recreate this part. We almost have all of its geometry defined. There are a few things missing though, and this includes the dimensions of the holes on the flange, which is seen most clearly in the right side view. So we can actually use the hole and thread tool to dimension these features. So I'll select that tool in the toolbar, and then I can just click on the edge of one of these holes, and it will automatically generate a dimension for those holes. So it has M8 times 1.25-6H as a designation. We have a counterbore of 10 millimeters with a depth of 3 millimeters. And since we have 2 holes in this view, we can exit out of this hole and thread tool by right-clicking and pressing OK or pressing Escape. And then we can double-click on this dimension and just update it by adding a quantity note of 2 times here, since there are 2 holes on either side of this main hole. Just like we had to do with the hole, there is another feature that is currently undimensioned, and that is the chamfer on the tops of these top cylinders. So we can use the chamfer tool for that. I'll select that tool, and then all I have to do is click on the chamfer and one of the edges associated with that chamfer, and it will automatically generate a dimension for that, 1.5 times 45 degree chamfer. The 1.5 is the distance, the 45 degrees is the angle, and that finishes off our chamfer dimension. So again, we can right click and press OK or press Escape to exit out of that tool. And we're almost done. We almost have everything dimensioned. I'm just going to drag over my front view and top view so everything's positioned a little more nicely. And let's find out what we still need to add. Well, one very important feature is the fact that we shelled out this part, so we have to indicate the wall thickness somewhere. And we could do that on the top view, where we can clearly see the hidden lines indicating the thickness of the wall. So again, I'm going to move my front view down a little bit, and my right view will move with it. And that leaves some space to add a note here for the wall thickness. So I'm going to select the leader text tool from the toolbar, and that allows me to create an arrow extending from the wall of this part. I just have to click and then right click and press continue. And now I can add the note that I want to add, which is a note saying that all walls are 3 millimeters thick. And then I can press OK. Similarly, I want to add a note in the isometric view to indicate that this is a loft feature. So I'll just repeat the process here. I'm going to create an arrow from one of the edges of this loft. I'm going to click and then right click and press OK. And I'll just add the note indicating that this is a loft feature. And I'll click OK. And with that, it looks like we've included all of our dimensions. It's always good to go back and ask yourself, are all of the center lines here? Are all of the center marks included? Do I have all the dimensions needed to fully define my part's geometry? And if you can answer yes to all of those, then we're in good shape. Our title block is complete, so we can save this file and we're done.